Betelgeuse, a monstrous, red, supergiant star situated in the Orion constellation, is a surprising celestial object that has captured the interest of astronomers and astrophysicists alike for quite some time. If it were positioned at the center of our solar system, its size would extend far beyond the orbit of Jupiter, surpassing even the Sun. This titanic star's actual presence is immense and is also undergoing significant changes that could lead to a catastrophic event on an unprecedented scale. Scientists, including renowned experts like Brian Cox, have expressed concerns about Betelgeuse, as it has been emitting unusual signals throughout space. These developments have raised a crucial question. Could we be on the verge of witnessing a spectacular explosion that would dramatically alter the night sky? The mystery of Betelgeuse remains a source of fascination for the scientific community. Like living organisms, stars undergo birth, life, and death in ways that often challenge our understanding. Betelgeuse, a red supergiant, resides on the outer edge of our galaxy and has been the subject of much interest due to its colossal size and old age. Its reddish tint and variable brightness have captured the attention of both amateur and professional astronomers over the years. Its fluctuating luminosity and color changes have sparked curiosity, but recent events have intensified questions about its future. As Betelgeuse approaches the end of its life cycle, its sheer size is astonishing. It is more than 1,000 times larger than the Sun. In fact, if it replaced the Sun, its outer layers would extend far beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in the process. This massive size reflects its current stage in stellar evolution. Having depleted the hydrogen in its core, Betelgeuse is now expanding and cooling, signaling that its end is near. Betelgeuse is estimated to be around 8 to 8.5 million years old, which may seem relatively young by human standards but is quite old in terms of stellar lifespans. Over millions of years, this star has undergone dramatic changes, evolving from a hot blue star to the cooler red supergiant we see today. These transformations are driven by the balance between nuclear fusion and gravitational forces, which cause stars to expand and contract throughout their lives. The red hue of Betelgeuse results from its lower surface temperature compared to hotter stars like the Sun. While the Sun's surface temperature is around 5,500 Kelvin, Betelgeuse's is much cooler, at approximately 3,500 Kelvin. This lower temperature causes Betelgeuse to emit light at longer wavelengths, giving it its characteristic red appearance. However, this color change is more than just an aesthetic feature. It provides astronomers with valuable insights into the star's internal processes and ongoing evolution. Betelgeuse's color and brightness have not been constant over time. Ancient civilizations, including the Romans and Chinese, once described Betelgeuse as yellow, and it was only in the 9th century that Arabic astronomers noted its shift to red. This color change marks the star's natural progression from a hotter, younger state to the cooler red giant we observe today. In addition to its changing color, Betelgeuse is classified as a variable star, meaning its brightness fluctuates over time. These variations occur over both short-term cycles, lasting days, and longer-term patterns, spanning years. Unlike many stars that exhibit predictable brightness trends, Betelgeuse sometimes deviates from these patterns, suggesting that complex, not yet fully understood processes may be occurring within it. One of the most remarkable events in recent history was the Great Dimming of Betelgeuse in 2019. This unusual phenomenon sent shockwaves through the scientific community, as Betelgeuse, typically one of the brightest objects in the night sky, lost a significant portion of its brightness. The star's luminosity decreased at a rate of 0.01 magnitudes per day, reaching its dimmest point in February 2020. This drastic change raised many questions about what was happening to the star. One of the challenges in studying Betelgeuse is the delay between an event and its observation on Earth. Light from Betelgeuse takes over 725 years to reach our planet, meaning that when we observe the star, we are essentially looking at how it appeared in the past, not in real time. This delay makes it difficult to track rapid changes in the star's behavior, complicating efforts to predict or explain its fluctuations. Because of these extraordinary observations, astronomers, including Andrea Dupree from the Harvard Center for Astrophysics, have been closely monitoring Betelgeuse using advanced instruments like the Hubble Space Telescope. These observations have provided crucial insights into the changes occurring in the outer layers of Betelgeuse's atmosphere. Data from the Hubble Space Telescope revealed that material was being ejected from Betelgeuse at speeds of up to 200,000 miles per hour, forming a dust cloud that partially obscured the star's surface and contributed to its dimming. This rapid mass loss has led some scientists to speculate that Betelgeuse may be approaching an even more dramatic event, a supernova. Is Betelgeuse about to explode? The big question remains, is Betelgeuse on the verge of a supernova explosion? A supernova is the violent death of a star, and if Betelgeuse were to reach this stage, its explosion would produce an incredibly bright burst of light, visible even during the day. This event would outshine the full moon and offer a rare opportunity to study the final moments of a massive star's life. However, despite the spectacular nature of such an explosion, Betelgeuse's distance from Earth, about 725 light-years, ensures that we would experience no direct harm from the event. Several theories have been proposed to explain Betelgeuse's recent dimming. One hypothesis suggests that it marks the beginning of the star's transition to a supernova. Another possibility is that a dust cloud, formed by the star's ongoing mass loss, is blocking its light. Some researchers propose that the dimming could result from changes in Betelgeuse's outer layer or photosphere, possibly due to the formation of a large dark spot on its surface. Regardless of the cause, Betelgeuse's dimming remains a significant area of study for astronomers. Red supergiants like Betelgeuse are crucial to our understanding of stellar evolution. These stars represent the final stage of a massive star's life before it explodes in a supernova. Their immense size and relatively short lifespans make them ideal subjects for studying the processes leading to a star's death. Furthermore, the energy released by these stars during their final stages contributes to the formation of heavy elements, which are essential for creating planets and life as we know it. If Betelgeuse were to explode, it would provide an unprecedented opportunity to observe a supernova up close. Supernovae play a key role in enriching the interstellar medium with heavy elements, which are then incorporated into new stars, planets, and potentially life. The eventual supernova of Betelgeuse could have profound implications for our understanding of these cosmic events and would offer a breathtaking spectacle for astronomers and stargazers around the world. While Betelgeuse's vast distance from Earth ensures our safety from any harmful effects, the study of its dimming and possible demise will continue to provide valuable insights into the larger processes governing stellar evolution. The cosmic importance of Betelgeuse. Betelgeuse's fate is not just an isolated event, it holds profound implications for our understanding of stellar evolution, supernova mechanics, and even the formation of elements essential for life. The death of massive stars like Betelgeuse plays a fundamental role in shaping the universe, distributing heavy elements that form planets, moons, and even the building blocks of organic life. When a red supergiant like Betelgeuse exhausts its fuel, gravity takes over, leading to core collapse. This collapse triggers an explosive release of energy, resulting in a Type II supernova. Such supernovae are crucial in spreading elements like carbon, oxygen, iron, and gold into space, elements that later become part of new planetary systems. If Betelgeuse does go supernova within the next 100,000 years, it would be one of the most significant celestial events observed by humanity. The explosion would be so bright that it could be seen even during the day and would outshine the full moon for weeks or even months. This would allow astronomers an unprecedented opportunity to study the final moments of a massive star's life in real time. What would a supernova look like from Earth? If Betelgeuse were to explode, it would be one of the most visually stunning astronomical events in recorded history. The initial blast would release a tremendous burst of energy, producing a rapidly expanding shockwave of light and matter. Here's what we might expect. 1. A sudden brightening. Betelgeuse would increase in brightness dramatically, becoming one of the brightest objects in the sky, even during the daytime. 2. A spectacular light show. The supernova would create a dazzling display of light, with remnants visible for weeks to months. 3. Nebula formation. Over time, the ejected material would form a glowing nebula, enriching the interstellar medium with heavy elements that could eventually form new stars and planets. 4. No harm to Earth. Since Betelgeuse is 725 light-years away, its explosion would not pose any direct threat. The only noticeable impact on Earth would be an increase in cosmic radiation, but our atmosphere and magnetic field would protect us from any significant effects. The legacy of Betelgeuse. The eventual explosion of Betelgeuse will mark the end of a star that has fascinated humanity for centuries. Ancient civilizations tracked its brightness, early astronomers studied its fluctuations, and modern scientists are now using state-of-the-art telescopes to monitor its every move. Once Betelgeuse does explode, the resulting nebula will persist for thousands of years, similar to the Crab Nebula, which was formed by a supernova recorded by Chinese astronomers in 1054 AD. Future generations of astronomers will likely study the remnants of Betelgeuse, just as we analyze ancient supernovae today. Final thoughts. Although we cannot predict exactly when Betelgeuse will explode, its behavior in recent years suggests that major changes are happening within. Whether it happens in our lifetime or centuries from now, one thing is certain: Betelgeuse's supernova will be one of the most extraordinary cosmic events ever witnessed. Until that day arrives, astronomers will continue to monitor this titanic star, searching for clues about its final moments and preparing for the spectacular show it will eventually provide. The universe's development and its hazardous passings assume a huge part in molding the eventual fate of worlds and star frameworks. As cosmologists keep on noticing Betelgeuse's changes, the information acquired from this famous star will probably offer new points of view on the more extensive field of heavenly advancement. The investigation of red supergiants and their possible fate gives fundamental data about how massive stars live and die. By understanding the components driving these cycles, researchers can make more precise predictions about the existence patterns of different stars in comparative phases of advancement. Betelgeuse's behavior may likewise assist with uncovering the strange elements affecting variability in stars. Space experts are probably going to utilize Betelgeuse as a benchmark for examination, concentrating on its fluctuations alongside those of different stars to refine models of stellar behavior. The mass misfortune saw in Betelgeuse offers a brief look into the outrageous circumstances experienced by red supergiants. As the star approaches the finish of its life, its external layers will likely turn out to be considerably more unstable, shedding significantly more material. Understanding this mass loss is vital for anticipating how other red supergiants will evolve. Supernovae are spectacular cosmic occasions, as well as being major contributors to the development of heavy elements throughout the universe. When a massive star like Betelgeuse detonates, it discharges elements such as iron, carbon, and oxygen, the structure blocks for new planets, stars, and potentially life itself. Betelgeuse's blast, if it were to happen, would add to this cosmic cycle, enriching the interstellar medium and preparing for new star frameworks. The shock waves from a supernova can compact nearby gas clouds, triggering the formation of new stars, while the radiation delivered during the blast can influence the chemical composition of these new stars and planets. Understanding these cycles is fundamental for predicting the fate of the universe. As Betelgeuse continues to evolve and display uncommon behavior, astronomers will intensify their efforts to study it using advanced instruments like the Hubble Space Telescope and various observatories. These continuous observations will provide crucial data that will refine models of stellar evolution, particularly in the areas of mass loss, brightness variability, and other phenomena that characterize the life cycles of massive stars. All in all, the investigation of Betelgeuse offers an invaluable opportunity to understand the life and death of stars, particularly those much larger than our Sun. While our Sun is a medium-sized star with a long lifespan, understanding the behavior of red supergiants like Betelgeuse allows us to make more accurate predictions about the fate of other massive stars. The insights gained from studying Betelgeuse can also expand our understanding of cosmic forces such as galaxy formation, star clusters, and planetary systems. As we continue to monitor Betelgeuse and other red supergiants, we will gain a better understanding of the fundamental processes that govern the universe, helping us answer some of the most profound questions in cosmology. Beyond the excitement surrounding Betelgeuse's potential for a supernova explosion, this star provides a rare glimpse into the final stages of stellar evolution. Its enormous size, erratic behavior, and looming demise offer valuable insights into how stars evolve and ultimately perish. The study of Betelgeuse not only helps us understand the complexities of this particular star, but also sheds light on the life cycles of other massive stars and their impact on the universe as a whole. As scientists observe Betelgeuse's evolution, they continue to view it as a natural laboratory for studying stellar death. Understanding its transition into a supernova, should that happen, will help us grasp how other stars of similar size and composition follow the same path. Supernovae are critical events in the life cycle of a star and serve as significant moments in the ongoing evolution of the universe. Betelgeuse's behavior, particularly its sudden dimming and fluctuating brightness, provides astronomers with an opportunity to refine their models of how red supergiants behave as they approach the end of their lives. While the exact cause of its recent dimming remains unclear, one thing is certain: Betelgeuse is a key piece of the puzzle in understanding stellar death and the cosmic processes that govern it. The massive mass loss observed in Betelgeuse is another fascinating aspect of its final years. As the star sheds material at such a rapid pace, researchers can learn more about the future and possible fate of similar stars. This mass loss not only signals Betelgeuse's impending end, but also contributes to our understanding of how red supergiants influence their surroundings. The material ejected by the star will eventually mix into the interstellar medium, affecting the formation of new stars, planets, and other celestial bodies. Astronomers, using both ground-based telescopes and space-based observatories, are continuously gathering new data on Betelgeuse. Observations from instruments like the Hubble Space Telescope allow them to gain a deeper understanding of the star's behavior and internal changes, helping to track how stars like Betelgeuse interact with their environment, especially in their final stages of life. These studies also offer new insights into how rapid mass loss and variable brightness shape the overall structure of our galaxy. The mass loss from Betelgeuse is particularly compelling, as red supergiants like this one expel enormous amounts of material into space, significantly affecting the surrounding interstellar medium. This process enriches the medium with heavy elements, which are crucial for the formation of future stars and planetary systems. When these elements are released into space, they become the building blocks for new stars, planets, and perhaps even life itself. As Betelgeuse continues its journey through the later stages of stellar evolution, astronomers are keenly aware that its eventual supernova could trigger the birth of new stars. The explosion would release vast amounts of energy, compressing nearby gas clouds and encouraging the formation of new celestial bodies. This is one of the fundamental ways the universe renews itself, creating the raw materials for the next generation of stars and planets. Although the potential for a supernova is exciting, it is unlikely to pose any direct threat to Earth. The vast distance between Betelgeuse and our planet, approximately 725 light-years, ensures that any harmful radiation or shock waves would not reach us. However, the observational data gathered during this process will continue to provide invaluable information on how stars evolve, die, and contribute to the life cycle of the universe. These findings will help us understand how future stellar events could impact other star systems within our galaxy. Betelgeuse's approaching demise, whether through a supernova or some other event, will be studied in great detail, not only for the wealth of information it provides, but also because it represents broader principles of stellar evolution. The star's behavior as it nears its end can teach scientists more about how stars of all sizes age and ultimately perish, allowing them to refine their models of stellar life cycles and the processes that occur when a star exhausts its fuel. As astronomers continue to monitor Betelgeuse's unpredictable behavior, they anticipate new discoveries that could reshape our understanding of massive stars. The star's fluctuations in brightness, rapid mass loss, and irregular activity suggest that it is undergoing complex internal changes. These observations provide valuable insights into the late stages of stellar evolution, helping scientists refine their models of how red supergiants transition toward their inevitable demise. One of the most intriguing aspects of Betelgeuse's behavior is the potential for a supernova explosion. While it is impossible to predict exactly when this event will occur, studying Betelgeuse in its pre-supernova state offers a unique opportunity to observe the processes leading up to such a cataclysmic event. Astronomers believe that when Betelgeuse eventually explodes, it will become one of the most spectacular celestial events witnessed in human history, briefly outshining the full moon and being visible even during the daytime. In preparation for this eventuality, researchers are utilizing an array of observational tools, including ground-based telescopes, space-based observatories, and advanced computational models. By analyzing Betelgeuse's spectral signatures, they can track changes in its composition, temperature, and luminosity, allowing them to detect early warning signs of an imminent explosion. This information is crucial not only for understanding Betelgeuse itself, but also for predicting the behavior of other red supergiants on the brink of collapse. Beyond its potential supernova, Betelgeuse serves as a key piece in the larger puzzle of cosmic evolution. The elements forged in its core and released upon its death will contribute to the formation of new stars, planets, and even the fundamental ingredients for life. This cycle of stellar birth and death underscores the interconnected nature of the universe, demonstrating how even the destruction of a single star can shape the future of entire galaxies. Moreover, the study of Betelgeuse provides a rare opportunity to examine the interplay between a dying star and its surrounding environment. The material expelled during its mass loss phases interacts with the interstellar medium, creating nebulae and other fascinating cosmic structures. These interactions play a crucial role in redistributing heavy elements throughout space, influencing the chemical makeup of future star-forming regions. As technology advances, astronomers will be able to study Betelgeuse in even greater detail. Future space telescopes, such as the James Webb Space Telescope and upcoming next-generation observatories, will allow for more precise measurements of its surface activity, internal structure, and surrounding stellar winds. These observations will help refine our understanding of how massive stars evolve and how their explosive deaths shape the universe. In the coming years, the scientific community will remain vigilant, closely monitoring Betelgeuse for any signs of dramatic changes. Whether it explodes in our lifetime or continues to undergo unpredictable fluctuations, its study will remain a cornerstone of stellar astrophysics. The lessons learned from Betelgeuse will not only enhance our knowledge of red supergiants but also provide a deeper appreciation for the cosmic processes that govern the life and death of stars. Ultimately, Betelgeuse's story is a reminder of the dynamic and ever-changing nature of the universe. Its eventual fate, whatever it may be, will serve as a testament to the intricate and awe-inspiring mechanisms that drive cosmic evolution. As we continue to observe and analyze this remarkable star, we are not only uncovering the secrets of its past and future, but also gaining invaluable insights into the grand tapestry of the cosmos.